Welcome to the first episode of my new Cultivate software channel, which will be all about smart software engineering practices that will help you with building better software faster. My name is David, and in today's episode, I want to show you how to solve a Codewars problem using a test-first approach. Solving a problem test-first essentially means we will drive the code development with tests. So instead of writing the tests at the end once we have the solution figured out, we will write tests while we are trying to figure out the solution. Here are the steps we will follow. First, we will write one failing test. Then we will make that test pass by writing the minimum amount of code necessary. And once the test is passing, we will clean up the code. Then we will repeat the process until we are satisfied with the solution. This cycle is also known as the red-green refactor loop of test-first programming. Developing code that way will feel awkward in the beginning, but it has many advantages. Here are three of my favorite benefits. You will be much more confident that your code works. You will be stuck less often and therefore overall faster. And you will be reminded to refactor and as a result write much cleaner code. I will discuss more benefits of test-first programming in upcoming episodes. Enough talking, let's get started. Here's today's Codewars problem. Breaking chocolate. Your task is to split the chocolate bar of given dimensions n times n into small squares. Each square is of size 1 by 1 and unbreakable. Implement a function that will return the minimum number of breaks needed. For example, if you're given a chocolate bar of size 2 times 1, you can split it into single squares in just one break. But for the size 3 times 1, you must do 2 breaks. If input data is invalid, you should return 0, as in no breaks are needed if we do not have any chocolate to split. Input will always be a non-negative integer. So we're supposed to implement a function called breakChocolate that takes two arguments, n and m, and that will return an integer. Okay, let's get started. Instead of limiting ourselves to the browser, we will use a proper IDE. My favorite IDE is WebStorm, and I will be using Node.js to solve this Codewars problem today. By the way, test-first programming is not bound to any programming language. You can test drive, for instance, Java, TypeScript, C++, or Python code. I'm going to use JavaScript, and my runtime environment will be Node 18. So let's make sure that I have Node 18 installed and set up. This looks good. And now I'm going to create a new subdirectory for my project. mkdir breakChocolate. Let's switch into this new directory. And then let's create a test file because we want to start with tests. Touch chocolate.test.js. Let's open this file. Here we go. So what could our first test be about? When it comes to solving problems test first, I usually want to start very simple. What is simpler than breaking a small bar of chocolate? Perhaps breaking no chocolate. So according to the problem description, that's actually a valid case. Let's start with this one then. So I'm going to describe a breakChocolate function. And as a second argument here, I pass a callback, a lambda function that will contain our tests. So the first test here, indicated by it, could be something like it breaks no chocolate when there is no chocolate to break. Same here. Let's pass a second argument, a lambda function that will be hosting our expect statements. And what do we expect? I expect that when I call the breakChocolate function with 0 and 0, then I expect the result to be 0. That's it. This is our first test. So let's run the test to see that it fails. npm test. So what we can see here now is that that didn't really work. It says no such file or directory, package.json. And in Node.js, that means that my project is actually not a Node project. So what I have to do is I have to first initialize it. I can do that with npm init. And so what it has done now for me is it has created this package.json file, which is kind of a manifest file for this project. So let's try that again, npm test. This time we get a different error message. It says error no test specified. And this error message actually comes out of this test script here. It says echo error no test specified. And what that means is that we don't have any test framework set up. So what I want to use as a test framework is Jest. Jest is the most popular testing framework when it comes to JavaScript development. Let's try that again. npm test. And this time it says Jest command not found. See what I'm doing here? Even though I don't have a test framework set up yet, I let the test command tell me what I should do next. What I like about it is that I don't have to remember all the setup steps or guess around. In this case, Jest is missing in our project, so let's install it as a dependency. npm install --save dev. Let's make sure that this is a dev dependency because we don't really want to ship Jest with our production code later, with our solution. It takes only a few seconds here, and then we should be able to run our test command again, npm test. The error message has changed again, but this time actually we can see that our test was executed. It just failed. And this test seems to be failing because of a reference error. It says break chocolate is not defined. And if you look at here, then in line 3 there, we're using a break chocolate function that is not defined. And the reason really is because we have not implemented it. So now we have a test that fails, and that gives us a reason to actually implement part of our solution. So what's the simplest thing we can do? Let's import this non-existing function and then let's create it. Import break chocolate from, let's assume it will be in the same directory in a file called chocolate.js. And then you see my IDE is already flagging this. Let's create this file. Here it is. I'm going to move it down here so that we can see the production code, the solution, at the same time as the tests. And here we're going to define this missing function, export const break chocolate. And we're going to define it as an empty lambda function, essentially a lambda function that has an empty body. Simplest thing that comes to my mind. But now I think we should overcome this error here. So npm test. And indeed, the error message has changed once again. Just encountered an unexpected token. And if you scroll down here, you see it kind of doesn't like the import keyword that I used here. And this is because Node by default doesn't support the new import export syntax. Now there are different ways of solving that. One of my favorite ways is to use actually Babel. Babel is a transpiler that converts my code into something that Node.js understands. So let's go to the internet and see what the documentation has to offer. On bubblejs.io, what you can do here is you can click on setup and then you will find a menu with recipes. And there's actually a recipe for Jest. So and it says, the first thing we have to do here really is we have to install bubblejs. Okay, let's do that. Let's go back to our IDE. Let's paste this command here. Takes only a second. Then it says in package.json, we are supposed to add this. But actually, I know that Jest is able to pick up Babel automatically. So we don't really need this. We can skip this. So let's just continue with this step here. It says that we need a Babel config.json file to load a preset. So let's install the preset first. The preset is basically a pre-configured set of configurations, and then let's create a babel config JSON file. Touch babel config JSON. Let's open it, and we have to make sure that we paste this in there. It essentially tells Babel to use the preset that we have just installed. Now, if I run npm test again, I hope that I don't see that error message anymore. And indeed, what I see instead is a different error message. The test fails, and it says expected 0, received undefined. And that kind of makes sense, right? We're expecting 0, but here we don't return anything. And in JavaScript, that essentially means that we implicitly return undefined. So what's the simplest possible thing we can do to fix this issue? Let's return 0. So let's run the test again, npm test. And now the test passes. Yeah, break chocolate breaks no chocolate when there is no chocolate to break. Awesome. Red, green. What comes after green? Refactor. So is there anything that we can improve in our solution here? I don't think so. It's really as short as it can get. But we should also look at the test code. Is there anything that we can improve here? Well, one thing I notice is a typo. So let's fix this typo here. But otherwise, oh wait, there's one more thing here. In Node, we don't really have to specify the extensions. Node is smart enough to find the file without the extension. So let's not write it. Awesome. Let's make sure that we didn't break the tests by running them one more time. Yep, the test is still passing. Red, green, refactor, repeat. So the next thing to do is to start over and to write another failing test. So what could be the next test? So what's the next simplest thing we could do? Perhaps we could say, well, that if we break a piece or a chocolate bar that has a dimension 1 by 1, that the function actually doesn't try to break it because it's already as small as it can get. So breaks no chocolate when there is only one piece. So let's specify the callback function for our expectations here. And in this case, what we want to say is, if I pass a piece or a chocolate bar that has the size 1 by 1, then this is non-breakable. We should expect 0 here. npm test. And this test actually passes immediately. And this is because we are hard coding as a return value here 0. That means actually, yeah, this satisfies both tests. In general, that's a good thing, but you want to be really careful when it comes to test-driven development, because there is a good chance that you actually created a false positive test, a test that is always green. So what we could do here is we could maybe just change this to something unexpected and see if our tests start to fail. npm test. Both tests are failing now. And this kind of tells me, okay, the tests are good enough. They are failing when they should fail. And I have a bug in my code, they fail. So let's revert this. Let's run our tests again. And now both tests are passing again. Red, green, refactor. I don't really see anything that could be improved here. But what I don't like is that I have to type npm test all the time. So just has actually a pretty cool feature that's called the watch mode. So let's configure that real quick here. So let's add another script, test watch. And let's make sure that when we use this script that it actually starts jest in the watch mode. Save that. And now when I say npm run test watch, it will run my tests as before, but it will also stay in this interactive mode. And when I now change either the solution code or the test code, and then save the file, my tests will immediately be re-executed. If I change that back and save that again, my tests will be re-executed. I don't have to do anything anymore. That's really convenient. Okay. Now we have two tests, red, green, refactor, repeat. What is the next test? What could be another thing worth testing? We have no chocolate, 1 piece. How about 2 pieces then? If you don't know, if nothing else comes to your mind and you think that makes sense testing, go ahead and test that. Yeah. Breaks chocolate once maybe when there are 2 pieces. All right. So expect when I call break chocolate with 1 and 2, with a chocolate bar that has the dimensions 1 and 2, then I expect the result to be 1. Yeah, a chocolate bar with these dimensions can be split exactly once. So I'm going to save that, and immediately my tests are re-executed. And what we see here is the first 2 tests are passing, but the third test is failing. Yeah, it says expected 1, but we have hard-coded 0, so we have received 0. And this is what I call a valid failing test. It fails for the right reason. Now we have the permission to again improve our solution. So let's open up maybe the function body here a bit so that we have more room to breathe. And now maybe we could say something like, well, it looks like we have to look at the arguments now, n and m. So maybe we could say if m is 2, then return 1. I'm going to save that. And indeed, this satisfies the new test, and also the previous 2 tests are not broken. So what comes after red, green? Refactor. Yeah, so what can we do here? Maybe we could turn this into a ternary. So we could say return m equals 2. If that is true, then return 1, otherwise return 0. I save that. The tests are still passing. This is essentially now dead code, so we can delete this. And now we have only the return statement left, so we can actually shorten that in the lambda syntax. Let's save that. The tests are still passing. Nice. What else can we improve here? Maybe we could also remove this n. And we didn't really use it. And a common way of handling this is to use underscore to indicate I'm not interested in this first argument here. Now let me point out one thing that might seem a bit strange to you. Hard coding the 2 here and also this underscore, ignoring n essentially as first argument. We know it's wrong, so why would we write code that obviously is wrong? It's actually not a bug, it's a feature. Test first programmers hard code all the time. And there are at least 2 reasons for that. Number 1, it saves time. Hard coding is often the simplest possible thing to do, so why should we spend more effort on finding a more complex solution? And number 2, it's a reminder that there are still missing tests that need to be written. When it comes to test first programming, we deliberately use hard-coded values as reminders that we're not done yet. The 2 reminds us that we cannot handle chocolates with more than 2 pieces. And the underscore reminds us that we still have to write a test that makes us evaluate the first argument n. So let's improve our tests so that we get a reason to look at the first argument n. What could we do? We could maybe write another test that receives, where the function receives 2 as first argument and 1 as second. And yeah, we could do that, but I think both tests would still carry the same name, breaks chocolate once when there are 2 pieces. So in this case, what we could do instead is we just add 2 expectations to this existing test. Let's remove the second one here and let's save this. And now our third test is failing again. It says it expected 1 and received 0 here in the second expectation that we just added. So what can we do about that? Maybe let's open up the function body here again and let's do the simplest possible thing that comes to our mind. So maybe we could say if n equals 2, return 1. I'm going to save that. And now what we see is that fails. It says reference error. N is not defined. Ah, right, yeah. I actually forgot to specify it as an argument. Let's save that again. And now our tests are passing again. Red, green, refactor. So what can we do? Maybe someone points it out or you see it yourself, but actually if I multiply the first and the second number, the result is 2. And when I multiply this first and the second number here, the result is also 2. So we could essentially say if n times m is 2, then return 1. That works. And then in all other cases, return 0. I'm going to save that, and that works. And now we're essentially back to a ternary. We can turn that into a ternary. Return if n times m is 2, return 1, otherwise 0. Indeed. Let's remove that, and let's also remove this unnecessary return statement here. And this is a much shorter solution. Refactoring, done. What comes next? Repeat. So we need another test. We know our solution is not perfect because we're still hard coding the 2 here. So what can we do? Maybe let's break a chocolate that has, oh, I see here we have a typo. Let's break a chocolate that has 3 pieces. So it breaks chocolate twice when there are 3 pieces. All right, so what do we expect? We expect that when we call break chocolate with a bar that has the 3 pieces, then this function will break the chocolate twice. We see this new test is failing, expected 2, but we get 0, I guess because n times m is not 2, so we get 0. So let's open up the function one more time and see what we can do here. In this case, maybe we could say if n times m is actually 3, return 2. And that works. All our tests are passing, red, green, refactor. Now what can we do here? It looks like there's a pattern. This here looks very similar to this, but we cannot see it properly. So sometimes it helps to rewrite the code a little to make the pattern more visible. So maybe what we could say is if n times m is 2, return 1. And also if n times m is 1, return 0. And then we have this other case where n times m is 0. In this case, we also want to return 0. Let's save that, and that works. And I think this here is that code. We can remove this. I save that, it works, yes. And now, do we see the pattern? So it looks like we're, at least for the first three if statements, we always return n times m, but -1. So let's see if that works. Return n times m -1. I'm going to save that. And indeed, it works at least for the last 3 tests. The first test here with where we break a chocolate, where we essentially break no chocolate, is an edge case. This is a special case, but we have that covered down here. So maybe let's move that up. Let's try that again. And now we have a solution that works. These 3 if statements here. This is dead code because after the return statement, nothing will be executed anymore. We can delete that, save again. And this is a much, much cleaner solution. Can we simplify that further? Perhaps even bring it back onto one line. What comes to my mind is a trick that we can use in JavaScript. With the logical OR operator, we can provide an alternative value in case something is falsy. And 0 as a result of n times m, this is actually falsy. So if we provide 1 as an alternative here, then we could say subtracting 1 minus 1 results in our expected value of 0. So if n times m is 0, we take the alternative value 1 because this is falsy here. And then we effectively subtracting 1 minus 1, and the result is our expected 0. So this line here shouldn't be necessary anymore. I'm going to save that, and our tests are still passing. So it works indeed. What I like about test-driven development or test-first programming is how easily and quickly we can verify our assumptions. If we are right, we can confidently delete unnecessary code. And if we are wrong, we can undo our way back to a green test state. No problem. Usually you're only a couple of undos away from a green state when you use the red-green refactor loop. So let's simplify that. Let's bring that up onto one line, save that, everything is passing. Awesome. What's next? Perhaps we should test 4 pieces. We have 1 piece, 2 pieces, 3 pieces, so maybe 4 pieces. Breaks chocolate 3 times when there are 4 pieces. So we are going to pass here maybe a bar that has a length of 4 pieces, and we expect 3 splits. I'm going to save that, and the test is indeed passing already. It looks like our solution is handling that already. So what's next? Breaks chocolate maybe 4 times when there are 5 pieces. So we're going to parse here chocolate bar 5 pieces, and we expect 4 splits. Can handle this. What about a variant of maybe 4 pieces? You know, here we could say if we have a 2 by 2 chocolate, then we also expect 3 splits. Save that, it passes. I think we're done. I think our solution is already good enough. Now, where do we stop when it comes to testing? In general, we can say often it's enough to provide test cases for 0, 1, many. Yeah, so we have here no chocolate, we have or no breaks, we have here 1 break, and then we could say these 3 tests, they essentially represent the many test case. And that we didn't have to adjust or improve our solution anymore also kind of confirms that these last 3 tests are actually 1 test case. Yeah, we had to improve our solution thanks to this test, but here we didn't have to do anything anymore. So let's merge these tests maybe into 1 test, and let's call that, how about we call it breaks chocolate of any size into 1 by 1 pieces. Let's move these expectations up here and this expectation up here, and then we can get rid of these 2 tests that we just wrote. Let's save that. Everything is still passing. Now we have only 1 problem left, and that is this test here has too many expectations. More than 2 or 3 expects is usually an indicator that 1 of 2 issues is present in our test here. The first issue could be that we're testing too many aspects of our problem in 1 test case. And I don't think that's the case here because we just merged these tests after saying they are actually representing one test case. And the other issue here could be that we have redundant expectations. Here I would say that the last expect and the second expect, that they're actually just variations of this expect here. Yeah, so, you know, where's the point? At some point, there's no additional value in testing a bar with 4 chocolate pieces or 5 chocolate pieces if you have tested 3 already. So in this case, let's delete these expectations. They don't add any value. And now we are back to 2 expectations. That's good enough. So I think that's it. We're done. So let's submit our solution to Codewars and see what they say. I'm going to copy that here. We're going to Codewars and we're going to paste the solution in here. I'm going to test this now and we get an error. It says to load an ES module, set type module. Essentially it has a syntax error here. It doesn't like the export, but I don't think we need that here. So let's test that again. Okay, now it worked. It essentially used these 2 assertions here. So let's submit our result and see what Codewars says. What Codewars is doing now, it's essentially in the background executing like a suite of tests against our solution, and it likes it. Yeah, we are done. I want to point out here that this solution is not the only one. And this set of tests is also not the only valid set of tests. I've done this particular coding problem many times, and every time I end up with a different approach and also with a different set of tests. I can only recommend giving test-first programming a chance, especially if coding is a frustrating experience for you. What I love is the structured approach that I get and that I can tackle problems step by step. First, we started with a really simple test case. Breaking no chocolate is really a no-brainer. Then we looked at a chocolate with 1 piece only, then at a chocolate with 2 pieces, and with every test we got a step closer to the acceptable solution. What makes test-first programming really powerful is that it's a practice that has continuous refactoring built right into the development process. So refactoring is not just an afterthought. We've added, removed, and changed the code multiple times throughout this exercise. With a test-first approach, the code actually changes all the time. And this is also one reason why I recorded this video for you. It's impossible to understand and master test-first programming by just looking at the end result, because the final code does not show all the intermediate steps that were necessary to arrive at the solution. Test-first programming is a process that will feel a bit awkward in the beginning, but it will make you so much more confident and faster. So if you like this video and don't want to miss upcoming episodes, make sure to subscribe to my channel right now. See you next time. Bye.